Alright guys, welcome to our channel Coders Arcade. I hope so that I am audible. If I am audible to you, please tell me. Yeah, we are audible, everything is clear, board is visible, I am visible, mic is also very much clear, audio is coming clear, everything is good. Yep. So, we are going to start our session 14 of free placement DSA live series. Welcome to our Coders Arcade channel guys, and this is Ashank David. Let us start our DSA placement live series. This is session 14 and in today's class we are going to start with all new topic. That is going to be linked list implementation of a stack. So if you guys haven't watched our previous live sessions onto our linked list and stacks concept, I would highly recommend you to go ahead and like and watch those videos, because all those things which I am going to teach you in today's class will be some or the other way connected to the previous classes that we had gone through. Out of all those 13 sessions that we have gone, this 14th session is going to be related to all the 13 sessions that we have created. Then we have talked about stacks in the very beginning, we have talked about queues in the very beginning, we have talked about linked list, and on linked list concept I have spent a lot of time now, and I hope so that you guys are also clear with all the concepts which we have talked about in terms of linked list. If you have any doubts, I can see the chats also here, so if you want you can come here and then I can chat with you live so that I can clear your doubts. I can do that as well. So please do tell me that if you have any doubts, please, I'll be helping you about that, so don't hesitate to ask any doubts. In today's session, it might not be that of a big session, because today I'm going to just finish up one concept, and that is the concept of stacks implementation using linked list. So basically we are going to create a stack. Now in the very starting class, when we just started with the concepts of DSA, data structures and algorithms, I have explained to you about stacks and queues, correct? Now if we have done stacks and queues, then at that time I have explained what exactly is a stack and what exactly is a queue. What is first in first out, what is first in last out. So if you haven't watched those videos yet, I would highly recommend to go ahead and watch that. Today we will be doing those things only, but not the array implementation. Array implementation was already done at that time. In today's class we will be doing the linked list implementation of those stacks and queues. Alright. Now before I start with this live stream, I would like you to please share this live stream as much as possible for those people who want to learn DSA. Follow our previous videos if you haven't started, and if you are new to our channel, please do like, share and subscribe to my channel as well, Coders Arcade, so that you are updated with the latest technical stuff that is going on right now for placements. Well, without any further ado, let's get right into the concept, and let's start with the concept of stacks and queues using linked list. Today I am going to only cover up stack concept using linked list concept. Okay. Alright, so let us start. Now I have already explained to you about what exactly is a stack data structure. So if we talk about that, let me just bring this up the Microsoft whiteboard so that everyone understands what is the concept that we are talking about. Here in today's class we are talking about creating stack implementation of stack using linked list. Okay. Alright guys. Now, what is the concept of a stack? What does the concept of stack says? Stack says the element which goes in first will be coming out at last. That means this is what you call as first in last out. We have understood this before only. So we said that stack looks like this, and whatever element you push it in, that element goes in and that element gets settled down. Stack is the data structure which is closed from beneath, right? And if we are talking about keeping another element inside, that element goes just above that, correct? Now if I say pop, if I say that you have to pop, that means bring any element outside, then this element will be coming out first. Why so? Because the concept says that it is all about first in, last out. First in, last out. Correct? First in, last out. When we are talking about first in, last out, I mean to say that the element which went first will be the last one to come out, and the element which entered just now will come out first. The concept of phi low. How we had done the implementation of this using an array? So let's do a recap, okay? And in that recap, let us understand about how have we implemented the concept of stack using arrays. So we have taken an array, we had taken up an array, and in that array what I have done was, the array was, in the beginning the array was empty, okay. So I took a top variable, which was pointing towards the negative -1 index, okay, and the indexes in arrays are 0, 1, 2, 3, 4, 5, correct? Correct. Now I said I want to push, I want to do push, and if I am doing push, what will happen? Top plus plus will happen, top plus plus will happen, and using ARR of top, the array notation of top, I could have put the value, correct? And when I did this, this top which we are talking about being here will move from here to here, it will move, and then using this top itself we would put a value, let us say x. Now this x can be anything, let us take this x as 10. When I said push 10, like this I have told, right? Now when I said one more, push 20 for example, in that case again what will happen is top plus plus would happen, correct? Top plus plus would happen, and this guy would have gone here, okay, and using the same thing, this, I would have entered this 20 right here, got it? I would have entered this 20 right here. This was the basic push operation that everyone understood. So if I wanted to implement it using a linked list, I would have started by creating the linked list, and in the linked list I would have started by creating the node class. We already know and understood, we have already done in the previous sessions, right? Now after creating the node class, I would create a function called as void push, where inside I will start by creating a node, and then I would have, rather than using head, I would have used top as my head pointer, and there I would have, I will tell you. Let's do one thing. With the recap, let us start with the concept that we were awaiting for, okay. So for example, in general linked list what happens? We have a head pointer, right? This head pointer will point towards the first upcoming node, which is not there right now, because the linked list is typically empty right now, correct? So in this case what happens is, let's say that this is the head pointer. Right now this is pointing towards null because there is no linked list present, okay, because there is no linked list present. I am saying that I want to push, I want to do push, and I want to implement first in last out using linked list. This is the concept which we are here for in today's class, right? So in that case what I will do is, right now I will think that my head is not head but it is top. According to stack we are working, according to stack we are working, correct? Correct guys, okay, according to stack we are working. So I have taken top as the head, and then I have said that will create a new node n. So I will say node star n equals to new node val, and then I could have said the new node is created, correct? Let us say this is a singly linked list. I am just taking one example here guys, okay. The value, let's say it is 10, because I want, let's say I want to push 10, okay. So I said value is 10 in this case, value is what? It is 10 in this case, okay. So I said now n of next is equals to top, n of next is equals to top, or I could have said top is equals to n. Understood my point? This is gonna be doing the push. Understood my point, what I am trying to say? So like this we will be trying to implement our linked list concept. For that you should know about what is next, what is top, what is n. Understood? Let us see. We will go back here, and this is what we were trying to do in the array concept, right? In the array concept, array implementation, we did it like this, the push. And then I said I want to remove this element. To remove this element I simply said that for pop operation I would say top minus minus, okay. So what happened was this top would have decremented by 1 and this would have been deleted easily without any further issues. So all of these things we would have done. So with the help of this I was able to implement first in last out, that is philo concept in data structure using arrays concept. Now today we will start by doing the linked list implementation, okay. This is what it is, a linked list implementation. Let us start with code here. Let us try to code here first, okay. So I will go to my editor here. We are back into our editor, and now in this editor I will start writing the code directly. So let us see how we will be writing the code, okay. Because this is C++, we are doing hash include IO stream using namespace std, okay, using namespace std, okay, using namespace std. Int main, I have created the int main, we will use this later on, return 0 as of for now, okay. So now I will start by creating the class here first, okay. So I will say class node, okay, class node, okay. Now in this class node what I am going to do is, class node, class will be always finishing with semicolon in C++, so don't forget about that. Okay, now what will be the attributes of this node class? It will be the data and the next pointer, right? So I'm going to say int data and node star next. I'm taking up two things here, int data and node star next. As we know already, let us create a constructor. For those people who don't know constructors, I have the whole mastering C++ object oriented playlist already created. In the session number 2, I have explained you about constructors and destructors and each and everything. So if you have missed that, I will give the link of that playlist in the description below, and you can go ahead and watch those videos from our playlist, and you can master object oriented programming from there. You got my point? So let us continue from here and let us create a constructor here. So we know what is a constructor, we will create a constructor. For more details, please go ahead and watch that video so that you get better understanding about constructors and destructors and how that works. Apart from that, I am going to create a constructor first here. Constructor would be node int data will be the parameter of this constructor, because I know that this is going to take up the data as like this. Okay. When I create the object of this, later on it will be taking our data, correct? Now in this case, I will be saying this dot next is equals to this dot data, actually this dot data equals to data, and this dot, in this case we do not use this dot, we use this arrows in C++, more details on that playlist which I have created, alright. So next is equals to, I will say null ptr, okay. If you haven't watched our pointers video also, so make sure that you watch our pointer videos also, where I have explained you about pointers really well. I will give the link of that video also in the description below, okay, and as well as in the I button right over there, okay. Now in this case, our constructor and our node class is completed. Do not forget to write public, okay, do not forget to write public. This is our node class. Got it, everyone? If you have any doubts, please let me know. So tomorrow we have homework, Tom's World. Sir, tomorrow we have homework. What homework? I did not get you, Tom's World. Tomorrow what homework you are talking about? Have I given you any homework? No, I don't think so. Are you talking about in college? Okay, keep deleted, message deleted, Tom's World, message deleted. If you have any doubts, please do let me know. I am confused what you were asking. Okay. Alright, let us continue. If you have any doubts, please do let me know. Are you from the college? I believe so, you are from the college, right? Did you miss my class? If you have missed my class, please ask other students also. I have posted in the group as well about the homework. If not, if you are a subscriber here, then please tell me properly. I am not able to understand you. Anyways, let's continue. Let's continue. Okay, so this is the constructor, this is the attribute, this is the constructor, this is the attribute. Okay, now we will be creating our stack class, a separate class for stack which allows us to create a stack through it. You got my point? So I am going to create a class here. Let us say we will create a class here called as stack. This is going to be interesting from now, okay. And by default the stack, you can say the attribute, stack class attribute could be top. Now in the explanation also I have explained this, that in the explanation, this explanation also I have told you that in here we use what do we use? We use top. Are you getting my point? In the explanation I have told that do we use top also. So, in this case top should be our priority here for the attribute purpose. Okay. So, I am going to take the attribute node star top, and in the public section of the class I would create the constructor here, and inside this I will initialize the top is equals to null. Okay guys, I hope so. What I did is clear, because here you see top is just like the head of this linked list through which we are implementing stack. Are you getting my point? So, in this case what happens is that this class stack contains this attribute top, and in the public section of the class I have created the constructor through which I am initializing that top is equals to null. Now, remember, in a normal linked list it would be head pointer, okay, but in stack concept it would be top. This is head only, which is now acting like head, but it is top, because in terms of stacks we use top as terminology. Okay. Apart from this, we can now start with our first function, void push. Okay, void push. This void push function will allow us to push an element inside the linked list. Okay. What it will contain? It will contain some value that the user will be entering while calling this function. Okay. You got my point, everyone? So, what could be the concept of push? Start by creating a new node. So, I created the new node, node star n is equals to new node. I put the value right up there, and I said my node is created. After creation of the node, what I will do is I will say new nodes next, that is n of next, okay, will be taking up the value from the top. Of course, n of next would be taking up the value from the top. Now, what is the logic here? Let us understand right away. Let us understand the logic right away. Okay. I am going to write here. Imagine. Are you able to see this? Imagine we already have a linked list. Okay, let us say this is our linked list. It's a stacked linked list. Okay, I am imagining that some random linked list we had. Okay, we have it like this. Okay, and now this is gonna be our head. That would be pointing right here already. Correct? You see, stack is what? It is closed from beneath. It is closed from beneath, correct? So it is, this is, so insert at the head, I can say do insert at the head, and that will be the topmost element. So instead of head, I am taking it as top in the terminology. Okay. And I said that if this is the case, that if the linked list already is existing, we already have a linked list, in that case, what do we do first? First, create a node. How do we create a node? Right, node star n equals to new node. Are you getting my point? And here I would just call the constructor and pass the value. Okay, I have already explained you the meaning of how we created this node, right? Okay, apart from this, I am saying next step, do this. First step let us do, create a new node. So, I created a new node, there you go. It has some value, let us say 10 is the value, imagine 10 is the value, okay. And I said now that we have created it. Now, how will, my question to you is that how the hell we would connect this? How we would connect this? I need this node's address. Head is already pointing towards that address. Understood? I need this address to be stored right here. And I know that the head, or in this case top, is holding that address because it is pointing towards that. So, what I will say, n of next will take the value from the head. So, this value is stored right here. Understood? I said this value is stored right here. So, the second equation comes like this. Second equation comes like this, n of next, that means the new nodes next will point towards top. So that if a element is already existing in the stack, for example, I will create a stack here. My first element is already present and there are multiple elements though, okay. And I said that this is the top, this is the top. Now, I said that I want to add a new element, I want to add a new element, okay. To add this new element, it will sit right here, correct? It will sit right here on the top only. So, this would require this address, right? This element would require this element's address so that it can sit and connect it on its top, correct? Who has this address? This top has its address. So, I give the address right here for the newly created nodes next, so that this connection should be made. You understand my point? And for that reason only I would have done this. And because the top is right now pointing towards, the top right now is pointing towards this node, right? I want to rotate it this way so that it now points this way, right? Not this way. So, for that, can I write here number 3 point? Can I write here head, or in this case no head, in this case you say top, you point towards the where? N. Are you getting my point, guys? Is this clear? This 3 lines of code would be our push function. Are you getting my point? Right. So, let us go ahead and code for it. So, first thing is done, creation of node. Second thing is n of next is equals to top. This is when the linked list already exists, or in this case the stack is already filled with some element. Got my point, everyone? This is it. Now, next, head should point towards n, right? In this case we do not have head, but in this case we have top. Got it? And ladies and gentlemen, there you go. This is your push function in linked list. I hope so that this is very much crystal clear to every single one of you. You have any doubts, please do ask me. So many people are watching, but you guys are not asking any doubts. Please do ask doubt if you have any, because if you don't type, if you don't ask doubts, then how your things will get clear, right? Which we are talking about, right? So please ask some doubts if you have any. All right. Next up is going to be our, or let us try this first, right? I'll create a display function, so that I'll be able to display the linked list. So I'll say void display, and in this case, how we would display, you know already, we have done this many a times. We will create a temp variable and we will traverse, make it traverse to the every node while it is printing the node's data. Understood? So in this case, you see what I will do is, I will create a node star temp equals to, we will start it from the top, we will start it from the topmost element, and then I will create a while loop till temp is not equals to null, which means until and unless temp doesn't becomes null, it will keep on doing, keep on doing what? Cout, I will access the temp of data, and then I will print some space, or maybe in this case I can print a arrow key so that it looks nice. And then I can say temp, once you have printed the data, once you have started from the top, you have printed the data, now you move in the front. How the temp will move? If I ask the temp to access its own next. So in this case, I will say temp is equals to temp of next, like this. Well, I hope so that this is very much clear now. This is wrong. Now it is clear. Alright, temp is equals to temp of, not here, temp is equals to, temp is while temp is not null, keep on printing this and then say temp is equals to temp of next. Okay, this is the code for it, to traverse and to print. Okay, to traverse and to print, and then at last I will say cout, I will print null, and then after doing that I will go to the next line like this. This is our display function, guys. So let's test it out really quick. So I'll go to my main function, and here I'll start by creating the stack s object, because we have the stack class here, and I'll just say cout, I'll print here push operation. Okay, go to the next line and I'll say s dot push. After saying s dot push, I'll say, let us say push 10. Okay, let us say push 10. I'll say s dot push, I'll push 20. I'll say s dot push, I'll say 30. Okay, I'll say s dot push, I'll say 40, like this, and so on. Imagine I have pushed these many elements right here there. What I'll do is now s dot display, and once I have done displaying this, I can run the code and you can see how it works. You see, push operation is working absolutely fine, no doubts in it, no problem in it, everything looks way too clear and fine. You got it, guys? I hope so that this is very much clear. Okay, next let us do pop operation, shall we? Let us do pop operation. So in this case, let us do pop. Okay, so in this case we will create a function called as void pop. Okay, and I need to check for the underflow condition, because if the user keep on doing pop, what will happen? At some point of time, the stack will get prematurely empty, and when it gets emptied, it will not be able to do anything. In that case, I can just print that stack underflown. If you want to do stack overflow condition also, by the way, in push, if you want to do that, then you can also do that as well, no problem in it. But you need to just calculate the length of the linked list first, like how we have done it for position, in insert at position, where I have done that. In that case, you need to do that right here, where you will calculate or get the current size of the linked list using the get current size function, and then from there what you will do is you will take a size variable and calculate the size of the linked list. After that you call it here, understand the size of the linked list, and then do what you say, if the n of next is equals to that particular size, okay, or maybe I have to just change it according to the count. I will keep on counting while I am iterating. As soon as the count reaches equals to the size, we will say that overflown condition is met in that case. Okay, so you can do like that also. Okay, that is also an option. But remember that we are trying to build this pop, and this pop should be what? This pop should be as perfect as possible. Okay. So, and this is a regular condition that you will see alongside. So, we will check for the pop condition. What will be the underflow condition? If top is equals to null. If the top is equals to null, that means there are no elements already, it is emptied. And if this is the case, then you can say here stack, underflown. Okay. Like this, and you would have said just return, do nothing. Okay, this is your underflown condition. I hope so that this is very much clear to all of you. Okay, how you will delete it? You will take a node to delete variable where I will store the top, and once the top is stored into to delete, I will move the top is equals to top of next, and then I will say delete to delete. To delete. Okay. You got what I have done for pop? I guess so. I hope so that this is very much clear to all of you, right? How did this pop function is working? How does this? Thank you, Chandan Kumar Sharma. Okay. So, how this pop is working? You see, we have checked for if the top is equals to null. In that case, what happens is that the stack is underflown, and then we have created to delete, where we have created to delete where we have stored the top. So, for example, if you want to delete this particular element, because this is the top, right? In that case, if you want to delete this, you will restore it and you will say top, you move one forward, top pointer, you will move one forward, and when you move one forward, this is invisible, then you delete this using delete dynamic memory allocation. This is what we are trying to do here. Store that top, the current top, then move the top to the next one, and then delete that to delete which you were doing this. Thank you, Tom's World. Thank you, Chandan Kumar Sharma. All right. Next up, let us carry on. Void push, void pop is done. What else we have done for our concept? We have int top we have created in terms of arrays, but we will be creating our, because top here is already a pointer and we don't want to get confused from that. So, what we will do is, let us create peek function. This is fine. I will create a peek function where again I have to check for if top is equals to null, then in that case we will say cout stack is empty again, or in this case we cannot just see anything, no, if the stack is empty, so that condition has to be checked once. And then I have said return -1. Now this is int peak, because we are returning an integer value, I try to return that also, so that it works absolutely fine, it does not give us any error. Okay. Now this is the thing. Later on I will say return top of data. Of course I will return top of data, because I just want to peek which element is on the top. So if I print the top's data, we get to know. Understood? If I want to get what is on the very top, top is pointing here, so I will just print top's data, which will print me this 10, this 10. I hope so that this is very much clear. Okay. Now what else function we have done before? There was one more function, guys, if you remember, that was bool is empty, boolean is empty, okay, where it will tell us if the linked list or the stack, in this case of course implemented using linked list, is empty or not. If it is empty, then it would return me that. So I will say return top is equals to null. You see, it is very simple here to understand. In one line we have done this. This is a function which is returning boolean value. So I am saying return top is equals to null. If it is true, it will return a boolean value, it will get automatically translated into a boolean value, and it will be kept like that and it will be returned. So if really top is equals to null, then in that case this would return true, and if it is not, then it would return false. So in one line you can do this function. I hope so that this is very much clear. So that's it, guys. We have done our stack class, where we have created our top as the main head pointer here, and we have created push, we have created pop, we have created peek, we have created isempty, we have created display, we have created our main function where we have just tested for push. Let us test it for pop also. So I will say cout, we are going to do now pop operation, okay, pop operation. In this case, let us say correct. Okay, so how will I do? S dot pop, okay, and I will say S dot display. Let us see if it works or not. So I have said S dot pop, but that means one element should get deleted in this case. You see, push, we were doing 10, 20, 30, 40, and on the top what is pushed right now? 40. So 40 got popped out. Understood? This is very much clear. If you have any doubts, please do let me know. Okay. Apart from this, let us do one peek operation. So I am going to say here peek operation. I will say and L, okay, and I will say cout, I will say top element is S dot peek, okay. I am calling the peek function, and this is going to peek on the top and give us the topmost element. So I will run this, and when I run this, you see the topmost element is 30. Of course it is 30, as we have seen it right now. Push operation 40, 30, 20, 10 null. Pop operation 30, 20, 10 null, because of course 40 got deleted here. Peek operation, the topmost element is 30, as we can see, correct? Alright. So like this, now I am going to test one more, and that is going to be the last one, which is empty function or not. So I will say cout, and I will say here is stack, because it is returning me true or false. So if it says yes, if it says true, I will print yes. If it says no, if it says false, I will print no. So let's see how we can do it. I'll use a ternary operator here. It's very simple. Is stack empty? If it is empty, so I'll put this whole s dot is empty. I have taken this s dot is empty function, it is, right? Question mark. If it is yes, like if it is true, then return yes. Okay. Is dot s dot is empty, s dot is empty, or it is s dot is empty. Question mark yes means if it is true, then return yes, otherwise full colon, otherwise return no. Understand a point what I have written here? I hope so that this is very much clear to everyone. This ternary operator function, correct? Now at last I am going to do here end L, so that for future purpose, if the thing is if many operations are done, then it is going to be like this. This is our function, guys. Okay, there is some error here. I don't think so that the error should come though. The error should be gone. What it says, expression preceding parenthesis of the parent call must have pointer to function. Oh, this actually should be here. No, everything is good. And L, yes or no? Everything is fine. What is the issue? What is the error? Okay, sorry. I have not used this insertion operator. Okay, got it guys, got it guys. Here is the stack empty, is dot, s dot is empty. If this is true, then return yes, otherwise return no. You got it, guys? I hope so that this is really clear about. Right. Let us run this. Is a stack empty? No, of course it is not empty. Let us do empty. Let us make it empty. So I am going to say the same thing again. 30 deleted, 20 deleted, 10 deleted. Now it is empty. So you see that it is empty. Okay. Stack is empty and -1 is written. By the way, one more correction I wanted to do, guys, here, and that is, I was talking about stack overflow condition, right? In terms of linked list is a dynamic data structure, and you cannot just fill up a linked list like this. Linked list will have endless number of nodes. It's a dynamic data structure, right? So you will never be able to write the overflow condition. That this was a surprise at the end. You might think that I would have told you about how to write an overflow condition for push, but it is not actually possible. You are getting my point? So that is what I am trying to explain, that this is the official linked list stack implementation. This is how you would do. This is how you would apply C++, object oriented skills. You use pointers, you use dynamic memory allocation to create your code, create the class for node, creating nodes in physical condition where we are putting values, we are doing push, pop, everything in details. If you have liked this video, please give us a thumbs up. And today we have got a lot of viewers also. I've got 100 views crossed, and the average view time is of course high as well. So thank you for watching, guys. I hope so that this is very much clear. Thank you for engaging, guys, and I hope so that this is really very clear. I'll provide the link to all the necessary files in the description below. So stay tuned for more content such as this. Every day I will be coming live at 7 o'clock for this week, guys. So stay tuned for more and more content like this. Also, if you have missed my C++ object oriented approach, mastering object oriented for C++, then go ahead and watch that playlist as well. Well, if you have any doubts, please do let me know in the chat. I am watching that chat, but nobody said anything till now related to the concept which I was teaching. I hope so that you have understood today's concept really well. If you are here till the end, thank you so much for watching, guys. Please do like, share and subscribe to our channel, as well as share this live stream to as many people as possible, so that they can also learn DSA for free. R4S, thank you sir. Unfortunately, I was like, do not worry about that, because all the live sessions which I am doing are going to be recorded and kept in a playlist. So you can go back and watch the same live again in a playlist. This is our 14th session, and all my previous sessions also are recorded, and those are kept in a playlist for mastering DSA in C++ for placement series. Okay, so R4S, do not worry, you have our playlist. Okay, still you have any problems or doubt, please do let me know in the comment section. I will be very much happy to create videos onto your doubts, and thank you guys for supporting me till here in my YouTube channel. So please do keep on supporting me in future also, and because of your engagement, we are motivated to actually create videos like these more, and for such more content, stay tuned. I'll be keep on coming live, and if you have any doubts, any problem, I'll always be there. And don't forget, guys, that we are also starting providing placements. I'm not talking about in my company, but there are many companies through which we are getting connected with. Okay, that we are getting connected with. So we will allow you to sit in interviews directly. So if you think that you are ready for the interview, you can contact us onto our Coders Arcade, into our Coders Arcade channel. In the about section, the phone number and our email is given, so you can contact us, register in our company, and we will provide opportunities for placements also. Right now, thank you Tom's World. Right now we are into the process of getting deals with many different companies for placements. So in future we are able to provide you placements also. We are trying very hard to get connected with those many companies, so that we can provide placements as well to you guys as a subscriber. So yeah, stay tuned for more content, and if you want to join us, please do let us know. I'm very happy to teach you, to train you, to get you placed, and that is my job. This is my favorite thing to do. So that's all for today's live stream, guys. I hope so that you have liked it, and that's all I would say. 1 hour is gone, 5 minutes to go, but in the meantime, if you want to ask any doubts for today's session, we have implemented stack using linked list. Okay. One more thing that is lagging behind in our videos is that we are not providing the code. So from today onwards, I'll try my best to provide codes also, the code which we are doing in the class, in the live session, in the description below, so that it is easily accessible to you and you can also use it for yourself. So I'll be doing that, and it's time to end this live session, guys. Tomorrow again I will see you at the same time. Sir, tomorrow pointer homework. Oh, you are from the class, today's class, right? Today's offline class I believe so, Tom's World, is it? Yeah, I have given homework actually on pointers, to learn pointers. So please do that homework. I believe so. Are you from my class in offline that we had today? I don't know. Well, we will see. Well, if you want to do homework, guys, I can give you some homework as well. So, if you want to try, like how we have done this, you can try implementing the queues data structure. Go back to my lecture where I have taught queues. I have implemented queues through arrays and try to implement the same thing using linked list like how I have implemented. Okay. Yes sir, JIT. Very good, very good. Yeah, so tomorrow in the class I will be coming and I'll asking the questions, okay, about that. I provided the links in the group as well. So yeah, in about this live session, guys, I'm gonna end this live session. Thank you so much for watching. This is Ashank David. I'll be signing off, and I'll see you guys again in tomorrow's session at 7 o'clock. Sharp 7 o'clock, I'll be back, and we will learn something new. For your homeworks, in your live stream homework, I would suggest you to do try to implement queues data structure using linked list, and let's see how we are able to do. Well, that's all for today's session, guys. I thank you so much for watching. I'll see you tomorrow. Bye bye. This is Ashank David signing off. I'll see you guys tomorrow. Thank you. Bye bye.